Okay, these are the notes for pre-calculus. These are 0.1 notes. We're talking today about linear equations and word problems. So our essential question for today, how do I solve linear equations and word problems? First, what are linear equations? Linear equations are equations that have an x in it. But what we mean by that is not an x squared or x cubed, etc. So all the problems you see on the front side of this paper are going to be linear equations, and then we have word problems on the back side. So to solve this, you want to get the x by itself. So problem number 1, subtract 3x. And divide both sides by 5. 2 equals x, or x equals 2. For the second problem, we're going to do something called distributing. You've probably seen that before. We're going to multiply 4 times 3x, 4 times negative 5, negative 2 times negative x, positive 2x. Multiply again, negative 16, and then this negative 6x is at the end, not in parentheses, so bring it down. And then I'm going to combine like terms. So I'm going to leave the left-hand side alone, and I'm going to put the 2x together with the 6x negative. That makes negative 4x. Then I'll combine my terms on opposite sides of each other by doing the opposite. So the opposite of negative 4x, positive 4x, or add 4x. Then add 20. And finally, divide by 16. You can write your answer either as a reduced fraction of 1/4, or if you'd rather turn it into a decimal, 0.25 is also correct. All right, how to deal with fractions. So there's 2 ways of how we're going to deal with these fractions. The first way, we're just going to start by subtracting the 16 over, since those are both whole numbers. And then we have that fraction. So option 1, how we deal with that is we're going to multiply by the reciprocal. The reciprocal of 1/2 is 2 over 1. Do that on the left, also do that on the right. And you can even turn 5 into a fraction, 5 over 1. The 2's and the 1's cancel, leaving you a equals. Then multiply the numerators together, 10. Denominators together, that's 1. 10 divided by 1 just gets us 10. Now, for example number 4, I can't do that same thing because it's not as easy to subtract 2 from 4/5 a fraction. So this is my option 2, in case option 1 is not available to you. We call it clear the fractions. In order to do that, we're going to need common denominators, and then we're going to cancel. So I'm going to start by putting everything as a fraction. So I'm going to put that over 1. And then you're going to get your common denominator. So look at 3, 1, and 5. Each of those numbers can go into the 15. So we're going to turn each of those into 15. So you can multiply 3 times what makes 15? That's 5. Multiply it at the bottom and top. 1 times what is 15? That's 15. Multiply by the bottom and top. 5 times what is 15? 3. Multiply the bottom and top. Now notice all of your denominators. I have 5 times 3, 15. 1 times 15, 15. 5 times 3, 15. All of them are 15. If all of them are the same, which is what we were trying to do, they cancel out. Then look at your numerators. 5 times 2 is 10x. 2 times 15 is 30. And 4 times 3 is 12. And then we would just solve it from there with no more fractions. Going a little fast on these, but if you need to pause the video at any time, feel free. Reduce this to negative 9/5, or if you want, you can type it into your calculator and get a decimal, negative 1.8. Example 5 is another example where we're going to want to clear the fractions. It's common denominator 3, 2, and 12. My common denominator will be 12. So I'm going to multiply by 4. I'll multiply by 6. And 12 is already 12, so I can leave that. Then I have got 12 and 12 and 12. If they're all the same, you can cancel them. And then just bring down the numerators after you've multiplied things together. And solve as usual. Five fourths or 1.25. On the back side, we're going to talk about word problems. My biggest advice for word problems, just make sure you read it. A lot of times word problems are easier than we think they are, but it's always good to get an idea without being too nervous about what the problem is about. Example 6, you have a rectangle 24 meters long, which has the same area as a square with 12-meter sides. What are the dimensions of the rectangle? So I'm going to start by just drawing a rectangle and drawing a square. Pictures often help. So especially if they've got something like shapes, go ahead and draw it out. So 24 as the length, and I don't know this, don't know the width, they didn't tell me. And then I've got the square is a 12 by 12, which technically all the sides are 12. I'm focused on the area here, so I'm thinking length times width. So I can figure out the area of the square. It's just going to be 12 times 12, which will get me 144. And then I have to make sure it's equal to the area of the rectangle. Again, I don't know the width, but I can just go ahead and put in a variable here like an x or even a w for width. And then divide by 24. Get x equals 6. So the dimensions of the rectangle, they don't just want the width of the rectangle, they want the dimensions. So this would be 24 by 6 meters for your final answer. If you didn't write out an equation, if you were just able to figure it out using your brain and your calculator, that's okay too. Any way you get to these answers is going to be correct and you'll get full credit. I don't always need to see the equation. Number 7, DeMonte earned $16 per hour for the first 8 hours of his shift. So that's kind of his regular pay. And then for each additional hour after the first 8, he earns $24 per hour. That's his overtime pay. If DeMonte earned $212 from a single shift, how many hours did he work during that shift? So again, if you grab your calculator and just start subtracting numbers, multiplying, things like that, you'll probably be able to get to the answer. I'm going to go ahead and do mine as an equation, just to show you how it's done. So we'll first figure out how much he makes for the first 8 hours. So it's $16 an hour times the 8 hours he works. I'll multiply that together to get 128. Then we got to figure out his overtime. He makes 24 hours, $24 per hour, but we don't know how many hours he works. So we can call that X. And I can't do anything else with that, so I'll bring it down. And then we know he makes a total of 212. So I'll bring that down as well. From here, you can see that we need to subtract 128. And then divide by 24. Now, the thing about these questions is, and this often happens in word problems, especially on things like the SAT, the answer you get is not actually the answer they want. They are asking how many hours did he work during the shift. So 3.5 is the amount of overtime hours, so we're going to have to add on 8 to that. And so then we get a final answer of 11.5 hours on his total shift. Right? 8 hours of regular pay and then 3.5 of overtime. And for the last one, we have two equations, B equals and C equals. In the equations above, B and C represent the price per pound in dollars of beef and chicken. So you have B and C, respectively. X weeks after July 1st during last summer. What was the price per pound of beef when it was equal to the price per pound of chicken? So this whole July 1st part doesn't have too much to do with it. We're just looking at X, which is the amount of weeks. So if I need these two equations to be equal to each other, if I need beef to equal chicken, I'm going to put the beef equation equal to the chicken equation. And I don't even need to include the B and the C because those are going to be equal. And from here, we're going to solve. Just be extra careful when you have decimals. I'm going to start by moving the 0.40. Then I'll move the 235 to the other side. Definitely using a calculator for this part. And then always divide by the number in front of the X. Again, typing that into my calculator. To get X equals 4. Now the X is 4, that's the number of weeks, the X weeks, but they actually, for the answer, want the price. What was the price per pound of beef when it was equal to the price per pound of chicken? So we're going to take our 4 and we're going to plug it right in here. And that's going to get us our price per beef, $2.35 plus 0.25 times 4. We'll use our calculator. Make sure you do multiplication first before you add, especially if you're using a phone calculator. If you're using the calculator on your Chromebook, like the graphing calculators we have in class, you can just type that all in there. And that's going to get you $3.35 per pound of beef.